Okay, hello guys. So right now what we did, firstly, I showed you the first step that for you to calculate for the question that can be asked is to show the first one. I just show you how to determine the nature of roots when you're given without solving the equation. That's how they can ask. Second, another question the way they can ask it is determine the value of the unknown. So the determining the value of unknown, for example, this is how I wrote it. For which values of k will x squared minus x minus k will have real roots. The important thing is this thing will have real roots. So it means that table, you must know that table very well. Make sure you memorize that table. But when you practice, like keep on using the table until this thing is in your head. Then you can now do those things. So now we are given the equation. So basically what we're going to do, we make sure the equation, make sure always that this equation is in the form of ax squared plus bx plus c is equals to 0. So yes, so this formula, this equation is like this: x squared minus x minus k is equals to 0. You see? So basically what we have, so let me just draw it on the left hand side. So we have x squared minus x minus k. So this thing is in the form of ax squared plus bx plus c. So we have to find our delta first. So we have b squared minus 4ac. Ne? So we have to find the delta first. Ne? So we know the value of a here is 1. And then the value of b here is what? It's minus 1. And then the value of c here is just minus k. You see? So this is the k that you have to find. You see? A, b. So make sure that always your equation is in the form of ax squared plus bx plus c. So now we are going to substitute here. We have what? B, which is minus 1 squared minus 4. What is the value of a? The value of a is 1. What is the value of this one? It's just minus k. So basically we have the delta, which is 1 minus 1 plus 4k. That's our delta. Okay? So you get the delta that is minus. So we know that when we have real roots, you need to know when real roots, it means our delta must be greater or equals to 0. Okay? So basically real roots, what we have, our delta must be greater or equals to 0. So when you see delta here, you can substitute this thing. So I will just do it over here. I will just do it this side. So what you're going to do is, where you see delta, you're going to substitute 1 plus 4k. So it's going to be 1 plus 4k must be greater or equals to 0. Then you solve for k. So when you solve for k, basically what is going to be, we're going to take one that other side. So it's going to be 4k greater equals to minus 1. Then k will be greater or equals to minus 1 over 4. That's the value of k. So k, for this thing to have real roots, the value of k must be greater or equals to minus 1 over 4. Okay, so guys, I'm going to do an example which is kind of difficult, but it's not really difficult. It's just on another level. It's just wants a bit of steroids. No, it's not a joke. You can laugh with me in the video. It's fine. Okay, so I'm going to do the last example about determining the unknown. So determining unknown, I'm gonna just change the equation here. For which values of k will this be? So let's say we have 3x plus 1 is equals to, we have 3x plus 1 is equals to x squared plus k, and then plus x. You see, now look at this equation now. For which values of k will this equation have real roots? Now, what you need to know, guys, is to put this equation in the form of ax squared plus bx plus c. You need to teach yourself of how to work with constants. So we have this thing like this. So we have to work with these things, that these things must be, at the end, it must be in this form. So what you're going to do, going to multiply this one plus this one. What do you get? You get 3 plus x, you get what? 3 multiplied by x, you get what? 3x. Plus, you get 3 is equals to x squared plus k plus x. You group them in such a way that it's going to have x and what. So, if I can take everything to this side, what am I getting? I'm left with 0 here. We have x squared, we have plus x. You can say put this x here. Then we have plus k. Then we have minus 3x. Then we have plus. We have also minus 3 when you take it to the other side. Okay? So those who have x, group them with those ones that have x. Those who are just constant, leave them as constants. So x squared is just alone. You see, x squared is just alone. And then what do we have again? We have plus x. It goes with minus 3x. Plus x minus 3x. So what I can see here is just x minus 3x. What is x minus 3x? X minus 3x is going to be minus 2x. And then we have what? K minus 3. Then we have plus k minus 3. So now I have to get my a and my b and my c. So this thing is all equals to 0. Right? So this thing is all equals to 0. So it means this part is just a constant, will be equals to my c. It means the value of a here is going to be what? 1. What is the value of b here? Minus 2. What is the value of ca? It's going to be k minus 3. Since this thing is it's a constant. You see it? Eh? Since this thing is it's a constant. So that's how the way I've cooked it. In the form of ax squared plus bx plus c. So now I'm going to discuss the nature of, now I have to get my delta first. So you have to find your delta. The delta is equals to b squared minus 4ac. So now I can substitute. What is the value of b? B is minus 2 squared minus 4. What is the value of a? The value of a is 1. What is the value of c? It's just k minus 3. So if I solve this thing, it's going to give me 4 minus 4k plus 12. So which is going to give me what? So this thing is going to give me 4 plus, we have minus 4k. 4 plus 12 is what? Is plus 16. Is plus what? Is plus 16. So this is my delta. So I found my delta. So after finding your delta, so I'm gonna erase this side also. So after finding your after finding your delta, what you do? You will explore. Now the roots, they say the roots must be what? Must be real roots. Since the roots must be real roots, we know that your delta is greater or equals to 0. What's the value of delta? Delta is just minus 4k plus 16. So we have minus 4k plus 16 greater than 0. Then you solve for k. So it's gonna, you will have to replace 16 to the other side. You get minus 4k is minus 4k greater or equals to minus 16. Divide both sides by minus 4. Divide both sides by minus 4. And you know when you divide by a minus, the inequality side, it changes. Né? When you divide by a minus side, the inequality side, so it's going to have k must be less or equals to 4. So guys, even when we do it by, so that's basically how you do. So determining the unknown. First step, what you do is you make sure you put that thing in a form of ax squared plus bx. Then the next step that you do, you find your delta. After finding your delta, basically you can answer any question. Let's say they said on this question, let's say they said for which values of k will this thing have what? Let's say they said this thing they have let's say they said equal roots. I'm just only changing here. You see, they said they have equal roots. So you're going to, it's going to also be the same procedure, but this thing, and you're going to put it in a form of ax squared plus bx plus c. Then you're going to get your delta. After getting your delta, then you have to know when it's equal roots, how will my discriminant be? Equal roots, it means my delta or my discriminant must be equals to 0. Then you substitute your delta, which is minus 4k plus 16 is equals to 0. Then you solve for what? For k. Then after solving for k, so basically it's going to be minus 4k is equals to minus 16. Then k must be equals to what? Must be equals to 4. So k must be equals to what? Your k must be, your k must be equals to 4. So that's how you. Okay, thank you guys. Okay, so the last part is when they're going to ask you about, okay, obvious guys, prove and show is like the same thing. So they will tell you whether to prove or show. Show that the nature of the roots have a given nature. So here in my example, I have to prove that the roots of this thing, we want to prove that the roots of thing, prove that the roots of this thing are rational and unequal. They are rational and equal if an n is an integer. So what we have to do here, we have to find the value of delta first. We have to, basically what we do here is to find the value of delta. So what are we having? We are having 2x squared plus 1 minus 2n, then x minus n is equals to 0. Then I have the value of a, which is 2, and then b, which is 1 minus 2n, is the package, ne? Then I have c, which is minus n. So now I have to find my delta. So I have to get my delta now and see. I want to prove that this. So I know when they say roots are rational, they must be, my delta must be, there are certain things that you need to know, basic stuff that you need to know, that when we say something is a rational, delta must be what? Must be greater than 0. Obviously it must be a real number and it must be rational. It means it must be equals to a perfect square. Perfect square is something we know it's square root. That's a perfect square. We know it's square root. As long as we know something is square root, that's a perfect square. In those, as long as it's a greater than, that delta is greater than 0, and then that number is a perfect square, and then the roots are rational and unequal. So let us prove that thing using our delta. So we're going to find our delta, which is b squared minus 4ac. Okay? So what is my b? So my b basically is equals to 1 minus 2n all squared minus 4. What is the value of a? A is 2, and c is equals to what? Minus n. Then c, and then the value of this thing is equals to 2 minus n. So this one we have 1 minus 4n plus 4n squared minus what? We can say plus, what is this thing? What does this thing give us? What does this thing give us? It's going to give us 8n. It's going to have 8n. So we can say this is 4n squared. We can have 4n squared minus 4 plus 4 is going to be plus 4. It's going to be plus 4. Then it's going to be plus 1. Then if, so guys, when the roots are like, when this thing is like this, it's very difficult to determine. So we can try and factorize this thing. Try and factorize this thing and see that you can find. So you can see that, guys, if we try to factorize this thing, we can say 2n and 2n. Basically it's going to be plus 1 plus 1. You see, the brackets are the same. Since the brackets are the same, I can just run here so that I can have more space. So the brackets are the same. We have two brackets that are common. So it shows me that delta is equals to 2n plus 1 all squared. 2n plus 1 all squared. You see, we have the delta, which is 2n plus 1 all squared. But if we put the square root here, anything that has a square, I told you guys from the previous videos that when we have something brackets and it has a square, we know it's square root. Then this is a perfect square. So what we can say is delta. Since delta, we can say, okay, since delta is greater, since this delta is greater than 0, and delta is equals to a perfect square. And it's also equals to, this in delta is equals to 0, and also delta is equals to perfect square. It means right over the roots are what? They are real, rational, and unequal. And we have proven this thing that the roots are real and rational. You see, we have proven this thing. So I'm going to do another example. So I'm gonna pause the video for a few minutes so that I can program this thing. Okay, so an example 2. We have another example 2 of basically showing. I told you guys that showing and proving is one and the same thing. So now we want to show that these things. We want to show that this thing, this thing is real. So what we want to show is that this thing is real. So basically, I've missed something here. So we want to show that this thing is real for all values of k. We want to show that this thing is real. Sorry guys, sorry. This thing is real for all values of k. So basically, what you need to do, first thing, we want to put this thing in a standard form. Or this thing like so we have to put it in a standard form, in a form of ax squared plus bx plus c. Guys, this one is a basic thing. Ax squared plus bx plus c. You must know it like you know your name and everything. Ax squared plus bx plus c. So that's how we must put this thing. So we have x squared. We have x squared minus kx plus k plus x is equals to 3. So first what you do, you group them in terms of x and x squared. So x squared is only 1. So minus kx, it goes with what? With something that has x. And then k is just a constant. Then we have minus 3 is equals to 0. Then when we combine them, we can say we have x minus, we can say x is our common factor here. So what are we left with? So basically here it's gonna be k minus 1. So it's gonna be k minus 1 plus k minus 3. So it's equals 2. So we're gonna have k minus 1, we have k minus 3. So we can say my a is 1 and my b is gonna be what? Minus. So my b is gonna be minus k plus 1, and my c is gonna be k minus 3. So now we have to get, I have to get my determinant, my discriminant, my delta. B squared minus 4ac. Then what is the value of b? So b is just minus k minus 1 all squared minus 4. What's the value of a? 1. And what's the value of c? It's just k minus 3. It's just the k. It's just k minus 3. It's just k minus 3. So what is it? This obvious, when you square this negative, it doesn't matter. So basically we're gonna have k squared minus 2k plus 1 minus, no, we're gonna have minus 4k then plus 12. So this thing is gonna be k squared. So this thing is gonna be k squared minus 6k plus k squared minus 6k plus 13. So that's my delta. Guys. Okay, I hope you are still with me, guys. Please don't get lost. Guys. So let us see, guys. When you are here, when we have something like this, guys, it's very difficult to really know. It's very difficult, guys, to really know whether the nature of roots is gonna be how. So basically what you need to do is either we have to factorize or we have to complete the square. So if we try to factorize this thing, we cannot really factorize this thing. So if you can't factorize this quadratic, try to complete the square. If you can't factorize it, try to complete the square. So we are going to complete the square of this thing. So we're going to have delta is equals to, well, you know, when you're completing the square, guys, you need to know those rules of completing a square. So these things are very important. You see, maths it's a map. It's like things are linked. So if you don't know how to complete the square for this one, so since, guys, it's not easy to find, like when it's like this, how are we going to say the nature of roots? How will it be? So we're completing the square. So we're gonna have k squared minus 6k plus 6 over 2 all squared minus 6 over 2 squared plus 30. So what are we going to have? We're going to have k squared minus 6k plus 9 minus 9 plus 30. So what are we having? We're going to have k minus 3 all squared plus k minus 3 all squared plus 4. That's our delta, guys. That's our delta, guys. So guys, as we explore this thing, let's check. It doesn't matter which value. It doesn't matter which value we can substitute here. The value of k, for example, for all values of k, if we can substitute, for example, when k is equals to 0, when you substitute k is equals to 0, it's going to be something that is greater than 4. Because at the end of the day, you're going to also square this thing. It's like it's squared. So when you substitute 3, it's going to be 0. So this thing, this delta is going to be greater or equals to 0. Because of, it's going to be greater or equals to 4. Basically. First, that's where we start. So this thing is going to be greater or equals to 4. So this thing is going to be, it will never be 0. Doesn't matter which value of k that we calculate, it will never be 0. But of course we know that if this thing becomes 0, it means they have equal roots, but they will never be equals to 0. Because it doesn't matter which value of k we substitute, because of it's going to all squared. So it's going to be, it's either 4 or it's going to be greater than 4. So it means now we can conclude by saying now my delta is greater than 0. And you know when delta is greater than 0, it means the roots is going to be what? They're going to have what? They're going to have real roots. So we're going to have real roots. So we have shown. So when you reach to this step, you have to come to this step of getting your delta. That from this equation, we can see that delta is greater than 0. Then we know that the roots are what? Then we can say roots are what? Are real. Then we can say roots are real. So basically, guys, what you need to understand is that table that I give you. You must make sure that you understand it and master it. So, for me, guys, it's done.